Hi, and a very warm welcome to all the people attending this podcast today. Today, we have with us Pradeep Sukumaran. He's the Vice President AI and Cloud Software at Ignitarium. Pradeep comes with over 21 years of experience in semiconductor and embedded domains, which includes AI, software business and engineering leadership, software design and development, sales and marketing, strategic initiatives on IoT and embedded vision, plus third party ecosystem management, and much more. And today in our discussion, we're going to cover some critical topics like AI industry as a whole, strategies of implementing and scaling AI projects, biggest misconceptions related to artificial intelligence, Ignitarium AI strategy for 2022 and 24, and some relevant use cases, which will be very interesting for us to know. So without any further delay, let's welcome Pradeep to this session. Hi, Pradeep.
Hi, Sejiti. Thanks for having me on this podcast. Happy to be here.
Yes, it's great to have you here. So, before we delve into how Ignitarium is doing business, let's understand AI industry a bit. So, with AI gaining momentum in the current era, what are the trends and the practices that you're witnessing in the industry?
Yeah. So, in fact, before answering that, let me just give you a short intro into what we do at Ignitarium, so that the points you're on make sense to all. So, we are a product engineering design house. We work for global clients and with a lot of focus on semiconductor-based product development. And in this context, AI for us means a lot of sensors that we deal with, the use of machine and deep learning software to analyze data from sensors such as camera, LiDAR, radar, and also some IoT sensors like the vibration sensors and temperature. And for us, most of the AI compute happens at the edge. Of course, there are implementations that we do on the cloud, but most of it is happening real time at the edge. And the industry verticals that we focus on, where we work with our customers, are in the areas of consumer electronics, industrial, medical, and also automotive. Now, the trends that we are seeing in this context specifically is what we call as the Cambrian explosion of AI hardware accelerators. So deep learning, as you know, has become a practical and deployable solution, mainly because of the compute that is available. And thanks to NVIDIA for triggering and initiating this almost a decade back, it's still the hardware of choice, the GPUs. But we are seeing many interesting different AI accelerator architectures and options that are now available for developers, right from low cost, low power hardware to some heavy duty hardware accelerators. And along with that comes a lot of mature software stacks and tools. And this open source nature of the world has really helped improve that. And we are seeing that this has made AI compute affordable, AI compute cheaper, and it's only increasing. And we want to see many more products which are going to have AI enabled features in them. And to add to this, from our perspective, we are seeing that the sensors that are being used, the ones that I mentioned, camera, LiDAR, radar, the sensor industry is also progressing well. They are making breakthrough technologies, making it more affordable and cheaper, especially the 3D sensors, which as you can see, are now available in phones as well with LiDARs. So it's only getting more interesting with compute and sensors, making big advancements in the last few years. A trend that I can point out in the field of deployment is the need and the use of what we call as MLOps. MLOps is a methodology that is being used, being tried out. It's still nascent in terms of its maturity. There are a lot of open source tools and different bespoke and custom implementations that are possible. But the need for it is driven by the fact that there are huge data sets, different types of data sets that we need to deal with. And corresponding to that, there are different AI architectures. As you know, there are new variations of existing architectures, or even drastically new architectures coming up every now and then. We see papers and implementations. So for AI developer, especially for companies like us, working on these for customers, it's important that we are on top of all the, let's say, experiments that we do with data sets and different combinations of art. It's getting messed up in one sense. That is where I think MLOps brings in some sanity, and helps us track and trace the important parameters for deployment. It could be speed, accuracy, and latency, and so I think this is an important trend, and we are hoping to see more of MLOps, getting into mature development flows. And related to this, there is a trend that we are seeing, which is data centric approach. The focus being how do you create better quality data sets. Of course, there is a lot of improvements that can happen on the model architecture itself, the algorithms and such, but I think data centric approach is something which a lot of the companies are looking at focusing. So that's one interesting trend. And the core tech itself, we've had machine learning, we've had deep learning. Within deep learning, you have CNNs, RNNs. Now there is something called as transformers. You would have heard about it. Just a few years back, I think Google triggered this, massive shift to very large scale implementations. We're talking about billion, parameters, even close to trillion parameters. And of course, these are for special, I would say large scale mega AI applications like language understanding. In fact, even I'm assuming for genetic, those large scale implementations. So transformers, I think, is something which is believed to take us closer to human level intelligence. Right? We are not there yet. AI is still, I would say, nascent in a lot of ways. But I think the progression seems to be in the right direction, where there is a vision to take this technology to general or human level intelligence. And Sejiti, for me specifically, and for a company like Ignitarium, the best part is the all of these trends that we are seeing. The progression is happening at a much rapid pace compared to, let's say, just 5 years back. We are seeing some interesting breakthroughs in the semiconductor world, in core AI, architectures, and all of this is happening in very short spans of time. So it's becoming difficult also in one sense for companies like us to keep one step ahead of these technologies, because there are customers who actually can do well with the use of such technologies and new hardware architectures and software implementation. So it's a fast paced world out there, and before things get worse, I think we all need to kind of figure out ways to keep abreast of what's happening. So definitely a lot of interesting things happening, and we just need to be on our toes and adapt as fast as we can.
Very rightly pointed out, Pradeep. It's a fast-paced industry, and to keep our relevancy and to keep this pace, we just have to keep moving fast. This brings me to my next point on AI projects, and my next question as well. Uh, so, thinking, implementing, and scaling AI projects are usually the three different aspects of involving AI in business. However, many of these organizations or companies still face this challenge to leverage it to its full potential and scaling AI projects to the required limit. Why do only 10% of these companies succeed with AI? What are your thoughts on it?
Yeah, so I think we're just seeing the start of the use of AI, practical AI. It's like I said, it's been a little more than a decade since it became practical in terms of deployments, but a lot of it still is, I would say, experimental stage. The customers that we are dealing with know that there is a value that can be derived. The processes can be improved using AI. I'm not saying the technology is nascent. Technology has improved a lot, but the practical applications, we're still probably scratching the surface of what's actually possible. So you say 10% of the companies have succeeded. I mean, there'll be reports which claim higher. I think it depends on who you talk to in the industry. I think we should give it some more time for the application space to mature. Definitely, it's not a hype. We've seen deployments that are there right now, which leverages machine learning, which leverages some very complex networks, some very interesting mix of sensors, sensor fusion. All these are happening. And there are challenges to scaling. We've been involved in tons of POCs that we've done for customers. And only now we are seeing some of them getting into the next stage of pilots and production systems. I think I mean, there are a couple of points which kind of, we should look at in terms of the difficulties that we have in reaching that full potential as of now. One clearly is from the consumer side, customers. is the expectation that AI can solve anything. This comes from probably the fact that there's an assumption that AI has reached human level intelligence. You have a problem, throw a brain at it, it gets solved. AI currently is not reached that stage yet. So that's something. Is not a magic wand. It's not a silver bullet yet. And I think the other thing is the tendency to look at AI, as a solution to all kind of problems. There are problems which cannot be solved or cannot be solved efficiently using AI. So that's one thing. And I think there's also the fact that you expect POCs to scale to the next level quickly, like production level quickly. I think there are challenges there, which all of us are trying to address. We need to kind of work with the customers in making that transition smoother. So all these are challenges, and we've not seen like great scale of deployments. But being the optimist, I think compared to what we would have seen some 3 to 5 years back, in the last 2 years at least, I've seen projects move from POCs to full scale deployments. So earlier we used to do like 2 to 3 POCs a quarter for customers in different areas, manufacturing side, infrastructure inspections and such. Now we are seeing those projects reach a stage where there is a need to take it to a good reason to take it to production. One other challenge that we have is on the data itself, especially for supervised or semi-supervised based approaches. Getting access to quality data is very important. For example, if you look at a system that can detect good and bad, right? Just simple good and bad detection. You have enough of data for the good type, but bad type, you don't have enough data. So either you solve the problem by creating bad data, simulations, augmentations, or you look at architectures which can work around that and work with more good data and less bad data. So I would still think it takes a little more time for us to see more deployments, and that 10% that you said should definitely increase as we go.
Correct, Pradeep. So you mentioned that there are challenges in scaling AI implementations or AI projects. So among the many industry that we know of, which one you believe it has the immense potential with artificial intelligence and has not been discovered or yet to penetrate?
Yeah, interesting. So I think AI has touched all the domains at varying degrees of let's say maturity. I don't think there's any core vertical industry that has not discovered AI already, either because the technology is good enough, or because they want to just say that they are AI. In the AI world, it's difficult to be seen outside of AI nowadays. Think outside of AI. Of course, the ones that have seen success are, in my view, the enterprise scale implementations. You've got your image search. Any of these consumer-facing applications, even video conferencing, there's a lot of AI features that are there now. There is fintech space where there is good mature solutions which deploys ML algorithms for different kind of inferences, recommendations, and such. So these are some of the more mature areas of deployment that we've seen. Where I see there is good potential is the industries that we are also catering to: industrial, automotive, medical, where there are a lot of R&D programs that are happening, and we get to work on some of those. Some of our customers actually have funds every year for seeing how AI can improve whatever product they're building, right? So we get to play a part in that. And I think if you ask the subject matter experts in these domains, these newer domains, I think most of them would say that AI is causing disruption. There's a lot of potential value that can be unlocked using AI. But I don't think they've reached that maturity yet. They've discovered AI, but I think they need to penetrate more. One domain among this where I feel personally, AI can do much more and would have greater impact on human life is medical. Of course, we have seen medical, AI being there in healthcare management systems, documentations, and all that. But the core applications in medical, like surgical robots using AI, assistive surgery, for example, or radiology, where AI, we are seeing a lot of action there. But definitely there is more that needs to be done. And hoping that someday we will, prolong lifespan, human lifespan, and AI would play a central role in that. There is genetic protein folding, a lot of those intense compute, which is now made more interesting by some of these newer networks that we talked about. And I think that's an area where I feel AI can penetrate more and play create a much bigger impact.
I totally agree. I think all the industries have already been penetrated by artificial intelligence, but definitely at a different maturity level, depending on which industry we are talking about. So, do you think this penetration or this maturity level, depends on any sort of misconception, or if you can tell us what are the biggest misconception that still exist in executives' mind, particularly when we talk about artificial intelligence?
Yeah, so I think we touched upon a few points in the earlier thing. So I think when we talk to our customers, there are two personas that we face when we meet customers. One is the engineering side, where they're doing product development and they clearly look at it from engineering perspective. And there are some challenges there when we start looking at solving a problem using AI. First thing is whether AI can solve that problem. Is it something which is like a magic wand? I have data, I have neural nets. Can I solve the problem? That's one. And second is how can you scale from a POC which is successful to production? Uh, so that's one challenge with that one set of discussions that we have with the engineering side. When it comes to the executives who are typically the decision makers, let's say the operation guys on the floor in the factory, for them, I think there is a feel or a assumption that AI can solve problems. If a human, can do defect detection at this rate, I would expect the system to do it better or as good as that. Now that's the target that we have, and we've implemented systems which do that, but it may not work in all cases. There will be some cases where it'll there's a case where it doesn't work in a particular scenario because of, let's say, in a vision system, because of lighting conditions or such. So I think people need to understand, executives need to understand that this is a system which is going to be deployed and it's going to start learning just like how humans learn. So you're going to bring an unskilled worker to a factory line, and you're going to get him trained, and you're going to have him work on that line, but he's going to pick up more and more and become better as it progresses. I think we need to understand that AI systems are work in a similar fashion. You create a model, you create those applications, but you deploy it. It doesn't necessarily be 100% accurate, but you got to give it time. So there are a lot of ways to accomplish that. What is expected is that the executives understand that this is an ongoing process and allow that to happen. And unless they do it now, they're going to lose out in the long run, in my view. Catching up would become probably more costlier. So we have come across customers who are savvy that way, executives who are willing to invest and go through that 3 months, 6 months of journey in trying to get a solution mature in the field. So things are definitely changing slowly, these misconceptions. And I think one thing that we have seen all customers do is take it as a POC in the first place. You prove the concept. So POC is a widely used term now, unlike the earlier days where POCs was only for very new unknown technologies. Now in the AI world, in most cases everything starts with a POC, because both sides really need to prove to each other that there is, from our side, the technology is good, from their side that there is ROI. And I think the ROI part is what the executives would keep as the top thing. ROI in terms of cost optimization or efficiency improvement and such. So I believe the POCs are a way to kind of make things clear to both sides of what is possible, draw boundaries on unrealistic expectations. And also this gives an opportunity to clear any misconceptions that are there. So it's an ongoing process, and the fight goes on both sides in terms of acceptance and clearing some of these misconceptions.
Correct, Pradeep. So now that we have understood a bit about the industry and how the leaders and the executives sort of think about this industry or take this technology to their business, let's talk a bit about Ignitarium's AI strategy. If you can explain that a bit, what is Ignitarium's AI strategy for this year and next? Are there any products and services that you are announcing in the current times? Also, I would like to understand which are the key industry verticals that Ignitarium is considering for their AI roadmap.
Sure, Sejati. So we've been focusing on AI for almost 6 years now. So we are a 10-year-old company in the product engineering space. We've been working on some leading edge technology all through, and so AI for us was something that we had to take dive. And it happened because we were doing a lot of work on semiconductors and multimedia software, and there was this reasons for us to start working on vision based defect detection solutions. So we started looking at that, and deep learning was sounded like it might solve some of the problems, so we started getting deeper and deeper. 6 years from then, we've made tremendous progress. We've kind of grown to a team which is almost 100 now, and we intend to scale to 150 by end of this year. This is the team that will focus on AI based implementation. So our focus has been on vision based AI, deep learning based implementations. We started off with 2D sensors. Now we're looking at 3D sensors, and we're now calling this as perception AI. So perception AI for us is the use of sensors like camera, 2D or 3D, LiDAR, even microphone, audio case also. All these helps the machine perceive its surroundings, and then we use AI, neural nets, and others to get some intelligence out of it. So this journey is continues for us, and we look at adding more and more of the latest technologies, be it hardware or software, to our service offerings. And we intend to focus more on automotive in the next 3 years. And the reason for it is because automotive, and by association robotics, where there is autonomous mobility as a key feature, is now seen as something which AI can really push to the next level. So we intend to play our part in this by focusing on perception AI software, deployment of those algorithms, optimization of those on some very interesting hardware architectures. There is some interesting paradigm shifts that are happening in the automotive world. Car is becoming software on wheels, as they call it, more software centric. We're going to see apps being available for car owners to download, just like they have phone apps, and a lot of it is going to have AI enabled features, and we want to be an enabler in this space. So we want to focus a lot on automotive. We have a very strong background in automotive in the chip design space and embedded software. So for us, it is an adjacent area in terms of the ecosystem. So adding AI to this is definitely going to help us increase our customer base. And we're also seeing within the automotive space, electric vehicles, being the next big thing, a shift from ICE engines to electric vehicles, and that basically means less mechanical, more electronics. And there is this domain of battery management systems that is very interesting, especially now that we are seeing a lot of the players coming in and creating two-wheelers, three-wheelers, and four-wheelers with battery for the electric vehicle, and a lot of them are not really built to standards. And I think one of the reasons is because of lack of battery management systems. And I think that is where a lot of good data analytics can help. So we are actually initiating an R&D project this year, where we're going to invest in creating capabilities and also solutions which will address this particular data analytics, or what we call as the BMS digital twin. So that's one area that we focused on. So there are initiatives that we kick off every year at the start of the calendar year, where the senior management, the core team, the technologists huddle up and we look at some of the trends. And clearly this year for us, AI was seen as the focus point. And so we've structured a lot of it around AI. And we intend to invest more, build the team on this. So in addition to automotive, we have been working on the vision-based AI solutions for infrastructure inspection and industrial applications. Infrastructure inspection is been a focus area for us, and we will continue to focus on that. Talking about civil infrastructures like railroads and roadways and bridges and all those, which now are finding a lot of importance in the developed countries because of aging infrastructure. Infrastructures that were built decades back now need a lot of maintenance, and the government is spending trillions of dollars to do so, and that's going to trickle down the supply chain to customers, our potential customers. We intend to capitalize on that. So that's on the application side of AI. On the semiconductor side, which is the core part of our company's capabilities and skills, we've been working with the hardware accelerator companies, and we intend to continue our offerings, which is to help them build more and better mature AI software SDKs. So while there are different hardwares available, what is going to be a factor for success is the maturity of the software that you can have. And I think that's where companies like Intel and NVIDIA specifically have done a great job in making their software stack so user and developer friendly that a lot of the things that are hidden, which needs to be hidden, are hidden. All the intricacies and the complexities of the hardware are abstracted, and the AI developer just focuses on using those to implement a solution in the fastest way possible. So the newer hardware architectures that are coming up also need similar software stacks, and we are already working with a few of them, startups, as well as even the tier one semiconductor companies who are looking at creating mature software development kits on their hardware. So that's will continue to be a focus for us. To summarize, we this year and going forward, we intend to stay focused on perception AI, sensor-based deep learning implementations, AI hardware platforms, and get more entrenched into the automotive and the adjacent robotic space.
Correct. Those are really good stuff that Ignitarium is planning to do, and we are really excited. We would look forward to that. If you can also talk a little bit about the AI use cases, how can we identify AI use cases that are highly relevant and will deliver maximum impact for your organization? Also, how people can do it, other organizations can do it. Can you also share some interesting business use cases that can substantiate your claims that we just mentioned?
Yeah. So So this is things that we have been through in the past few years, working with different types of customers and looking at their problem statements and seeing if AI can actually make that dent that they're looking at. And it all boils down to the ROI that you get at the end of it. When we start looking at problem statements, and we have learned this the hard way, where we at one point we used to take up all the projects that come our way and say, okay, let's plaster AI on it and see how it is, right? But then it really doesn't work out in the end. So over these years, we have kind of learned to identify what kind of problems really can be solved using AI. And I think there are a few criterias that we apply, and we have open, honest discussions with the customers, and look at practical ways of implementing it. No point taking the customer down a rosy path and show him a dead end. Right. So one is are there data sets that are available that can help us actually implement that solution, especially since we're looking at supervised and semi-supervised learning, and is there enough diversity or variability in the data sets? And that's an important discussion that we have. And where it's hard to apply rule-based or traditional algorithms, that is where definitely AI as a good can have a good impact. And there have been interesting cases where we look at problems and we see, okay, we jump straight to the end and say, okay, if AI cannot predict or cannot take a decision based on during the real-time inference, is the end result going to be catastrophic? Is it going to be life-threatening? Right. In some cases, in most cases, we feel it is not. False predictions are okay. Right. These are cases where you don't reach 100% accuracy straight off the bat. So this is where we have done some very interesting, I wouldn't call it workarounds, but additions to the solution, where we look at the model giving you certain predictions which are not which are low in confidence, but then you augment it at the system level using some other cues. So these are system level parameters that you take into consideration. So when we look at the problem statements, we try to discuss with the customer on the system level, implementation, to see if we can leverage some of that information to build more, stronger and better, implementations with respect to accuracy. For example, we build this AI-based voice command recognition software, which is expected to recognize certain set commands in different environments. And we know that it's going to have difficulties in certain environments. For example, when there is noise of a different kind that you've not trained for. So there are two ways to solve this. One, you do some in the field upgrades where you can adapt to the new environment, or you make use of some cues at the system level, which allows you to kind of improve the accuracy of the system as such. So we've done some interesting things there. Now these are some of the technical aspects. Now when you look at the uh, uh, business side aspects of it, definitely in a lot of cases we have seen that the human level intelligence is still cheaper than machine level intelligence. So when we go about implementing POCs, we realize that the humans, especially in developing countries, the human labor is still cheap, and you could as well use this, continue to use what you're doing, and kind of shift the automation plan a bit, down the line. But here also it's heartening to see that some of the customers are taking a longer term view. When you do the unit economics, the proposed solution may not meet your expectations. Like if you're trying to replace a labor, which is a few tens of dollars an hour, with a solution which is way costlier. Easy decision is okay, let's not do it. Let's continue with the human labor. But some of the customers, I see more of more and more of these happening, where they look at down the line. Now, what if I have to scale my operations? I have to go, for example, across lines, across factories. Then let me look at the unit economics, and that may not happen currently, but maybe 2-3 years down the line, the unit economics is definitely going to improve. So I think that's the kind of conversations that we have started seeing, which is unlike 2-3 years back, where a POC would probably be the end of the project, right? And all the hopes of AI, is dashed for both the parties. But now we are seeing, like I said, it's a ongoing process. There's good education that's happening on both sides. The way we explain also has improved. We are not looking at it purely from an engineering perspective, saying the tech is great, let's just put it. We're also trying to understand the customer's business, perspectives. At the same time, the customer is also understanding the current limitations of the technology as such. And I think there is some middle ground that we see. So yeah, it's quite encouraging that this is happening.
Very nicely described, Pradeep. Now that you have mentioned that you are critically working with some customers, what are some of the biggest challenges in working with these sort of customers on AI or ML based programs or solutions? Also, if you can also jot down some critical points that these customers or other companies should keep in mind when opting for an AI transformation for their organization.
Yeah. So when it comes to the challenges working with customers in these AI ML based programs, like I said, I've covered a few of the points earlier. One is clearly educating the customers that AI is not the one point solution. There have been cases where we've been able to break down the problem statement into subsets and prove to the customer that one or two or some subsets can actually leverage AI. But let's not make the complete solution AI driven. Let's do it in phases where there is areas where AI actually makes sense. And then when you bring the solution together, it's a combination of AI plus traditional approaches. Traditional as in rule-based implementations. For example, in the case of computer vision, we still rely a lot on standard, traditional image processing algorithms. Standard, rock solid implementations that are there to solve a particular problem. Best is to use that. and then you use AI for problems which actually require AI implementation. So that's one thing that we have seen, an hybrid approach to implementations. uh, Second is, when we look at problem statements, there are two aspects. One is the technology itself, that is AI, or the algorithm part of it, and then there is the domain expertise. When I say domain, is the industry domain expertise. So, example, if you are working with an automotive customer or medical customer, we would want the subject matter experts from their side to work with the experts on our side. So we bring in certain skills, which is the knowledge of these algorithms, implementations, how data sets can be prepared in a better way, what kind of neural net architectures are good. But we wouldn't know much about, let's say, the core automotive domain or industrial domain. Like, you're looking at gas pipeline detections and all that, right? So the subject matter experts from both sides have to work very closely. So uh, we've been pushing for that with some of the customers, saying bring in your experts, and let us talk, so that we look at both the aspects, your domain as well as our domain, and then propose a solution. I think that's something that I think is working well. And we also encourage customers to give enough time for the implementation to mature. So for POC could typically be, in our cases, we have seen typically 1 to 2 months, where you're quickly putting together some things and showing that there is feasibility. And then we propose what is called as a pilot phase. And pilot phase is typically another 3 to 4 months of work, where we take it to a little more mature stage with more data sets and finer models and all that. And then there is a production stage, the third stage, which could be 6 months. So most problems we have seen kind of can get bucketed into these three: a POC, a pilot, and a production phase in any of the industries that we have worked. And we educate these customers that it takes time. So be with us on this journey. There is investments that you have to do for almost a year to see the real benefit. If you're have the gumption and the appetite for it, then let's go on that journey. I think that's something which we are seeing more customers now opening up and saying, yes, there is some things we can do. There are limitations in budget, so let's do maybe a POC and a pilot, and then I'll get more budget from my higher management. So that's that cooperative, collaborative way of working is one approach that we have seen. So this kind of works around some of the challenges that we are seeing. So to your question on the critical points companies must keep in mind, when they're looking at AI to transform whatever area they're in, right? More or less similar, like look at problems that your experts in the companies feel that can be solved using AI. And we are seeing more and more company executives and operations actually reading up on AI. And it's very interesting to see some of them actually do hands-on now that it's becoming easy for anyone to start quickly. They talk to us in our language, and sometimes they even question our decisions, saying, oh, why are you using this way, why don't you use this network? And we're like, oh, okay. It's very interesting that they're also picking up the jargons and the terminologies. So that is one thing that we see companies do. So it's probably easy for them to kind of straight off say, okay, these are the problems we know can be solved using AI, right? So they're able to kind of pick that. Recently, we had a customer meeting, and the customer was very well prepared. Three problems that were there, and all of them he knew can be solved using AI. And he actually just, it was a very productive 2 hour meeting with a factory visit, where he exactly says this and this. Of course, there are complexities and implementations, but the customer was bang on in terms of the feasibility, right? And then one thing that we say customers is, again, don't expect 100% accuracies, maybe 85, 90, 95, depending on the system. And work with us to help improve that. So there are some implementations where we have given in-field training options, where the customer themselves can train while the system is in inference, real-time inference. They could take it offline for an hour, and train for the false cases that are seen, and then upgrade the software themselves. So click of a button, a few workflows, and you're done. You're ready with newer one. So working with the customer and making that easy is one thing that we have seen happen. So and like I said, the most important point that they have to keep in mind is we have seen unit economics, like I explained, uh, is just isn't there at the start of a discussion. So when you're looking at AI transformations and you go down to the brass tacks and you see, okay, if I spend a few dollars on machine intelligence, it's not going to work. I can continue with human labor, right? That I think they have to revisit and look at it longer term, right? So this, when the scale happens, and when the AI technologies improve, definitely it's going to beat the human labor cost at some point. So if that clarity is there, I think these are some of the points that the companies can keep in mind.
Okay, so Pradeep, you mentioned that there are times when you would not suggest an AI-based approach to a problem statement. Rather, you would rather go for an AI plus traditional approach, to solve a problem for one of the customers. Or are there any examples that you can share with us? What are these times when you don't recommend AI-based approach?
Yeah, I think there have been quite a few in the area of image, vision AI systems where, like I said, simple. I wouldn't say simple traditional. I mean, the existing traditional algorithms can do as good a job, and you save a lot of time in terms of deployment. You don't have to spend the POC time and all that. So there have been cases where for example, we had to look at a defect of an object. For a global client, there was a project that they were looking at doing, and they had done some experiments using AI themselves. So this is another point. We do have customers who have R&D teams within who actually are looking at AI. So they did some experiments and they found that yes, this kind of network could kind of solve the problem. Then they came to us to kind of improve the accuracy. Said, okay, tell us what it takes. Should we look at data? Should we look at the model architecture itself? And when we looked at the problem, we said, okay, help us understand the constraints in which you're going to deploy this, right? If you're looking at creating a generic solution, then yes, your approach is good, but it's going to be complex in terms of implementation. So give us a better understanding of the environment in which you're going to operate and what are the constraints. And when that clarity came in, it was clear to both sides that you really can implement it using image processing algorithms, and we actually did that for them. It was a complex implementation in terms of some of the coding and design that we had to do, but definitely we didn't end up using AI in that particular implementation. So I think conversations like this are important when we have discussions with customers, and we sometimes probe a lot with customers. Some of them even think, why are you asking me such questions when just do what you're told, which is to solve this particular problem using AI. But I think once you start peeling the layers, we find that it's not what it actually is. What it seems. You can still fix it using traditional approaches, and that's a good thing with us is we have seasoned that way. We've grown through that. This company has veterans in our midst who have been through that phase of using some of these older still valid technologies. So some of them are still, I would say some of them are skeptics within our company itself. They always challenge, why are you throwing AI at a problem, right? I solved the same thing years back using traditional approaches, so let's try that. So that's an interesting thing that we noticed.
Exactly the point. I think we should stop throwing AI at problems that can be actually still solved by the traditional approach. So we're sort of nearing the end, but I would like to understand a few more points. In an AI ML program, where does Ignitarium see a maximum time and energy spent? And are there avenues for automation that can minimize this in future?
Yeah, definitely. Definitely a lot of avenues for optimization. Like I said, this is an ongoing, process of, AI, the use of AI in different applications, and the maturity that we need to bring in terms of process and deployments and such. Typically, like I explained earlier, in our view, there are three phases. There's a POC phase, there is a pilot phase, and a production phase. And in each of these, for a typical, supervised based approach, there are three stages, I would call. One is data preparation. Data preparation is about data collection, cleaning, augmentation, basically getting data ready for the next stage, which is the training stage. And the next stage is actually a mix of model selection, model development, and training. In some cases, you are good to use your standard architectures, your REST nets, mobile nets, YOLOs, all those standard network architectures are there for you to use and, retrain using your data set. But in some cases, we've had to develop custom neural networks where we had to just start from scratch, use, frameworks, TensorFlow, PyTorch, and start building networks. And it makes sense in some cases where you just develop a 10 layer, smaller, layer CNN networks to solve your problem instead of using a big giant standard architecture. So that is the second phase, model selection, development, and training. The third is the deployment part. This could be on edge or it could be on cloud. And again, there are complexities thereof. So each of these phases that I mentioned, POC, pilot, and production, each of these have more or less the same three stages. You have data preparation, model side work, and then you have deployment work. What we've seen is that the data or the complexity or the maximum time and energy we spent is roughly the same order. We spend more time on data preparation part. I'm talking about good, reliable solutions that that you need at the end of this process. The second is the model part, and third is the deployment. Now, this is typical, but we've also seen cases, for example, in the production phase, when you do all that work, you end up spending, like I mentioned, productions could be phase could be 6 months to 8 months. You end up spending a good part of it on the deployment part, because that is when you actually are deploying it for the field, and you will find a lot of issues, and you got to, if you've not architected it properly from the beginning, you would face scaling issues, for example, especially in the cloud side. We've seen that happen. So roughly in this order: data preparation, model development, and then deployment. And each of these, there is a lot of automation that is possible. We have seen and we have done automations in all these three areas. Where we see easier automation possible is in the model training part. There are tools and methodologies that you can put in place. MLOps is one that I mentioned, where you can train and track and retrain and take it to the accuracy levels that you want, or speed performance levels that you want. And there are automations possible in deployments as well. And I think that's an important area, deployment, because like I said, people are now looking at over-the-air upgrades of models happening, even if it is edge or cloud-based. So you need to have good deployment mechanisms and automation. So I think some of those DevOps concepts also kind of fit in nicely there. Data preparation is an area where we have seen there is scope for a lot of automation. Not much has been done now. And one of the primary reasons is that still human in the loop is seen as the right way to do it. Because of the quality that you need from data sets, and the tools and automations have still not got to a level where you can, do, of course, you can do auto labeling and cleaning and all that, but it's not reached that level where you can just let automation take care of it completely. So we have semi-automation with human in the loop approaches in data preparation side, and we've done quite a few, some interesting work there for our customers. Yeah, so that's the way I would look at it.
Correct. Very nicely described, Pradeep. This sort of brings me to the end of this discussion. But at the start of the discussion, we spoke about how AI is a fast-paced world and how companies need to be on their toes to, keep up their relevancy and stuff. So, according to you, how do you foresee this year and the next turning out for Ignitarium in terms of artificial intelligence industry?
Yeah. So for us, in terms of revenue, when we started working on AI, it was more of an R&D initiative some 6 years back. And we've just trying to figure out what it means for us and for our existing customers at that point. And we've seen tremendous growth in the AI space for us in the last 2 years. We grew to a 100-member team, and we have scaled our plans for this year as well in terms of hiring people and training people to work on this. And this being a new field, it's not easy to find people who are who have experience in this domain. So we have created an intense, very interesting in-house training program with a lot of hands-on work on different kind of hardware architectures, different kind of deployments. So there is that focus that we have. terms of bringing up the skill of the workforce that we have. In terms of revenue, we've done quite a bit as a company. We've grown CAGR of over 55%, which is quite healthy for a company of our size. And all of this is bootstrapped. We have not, we're a company which is earning money and spending it to grow. No external investments and such, and we hope to continue in this mode. For us, AI is going to become in 3 years going to bring us 1/3 or more of our revenue. Right now, the maximum revenue contribution is from our semiconductor customers, where we do a lot of chip design and embedded software work. AI right now is around 10 to 15% of the revenue. The next 3 years, we intend to scale it to over 30%. And hopefully going forward, the company would look at AI as the biggest revenue earner in terms of the technology domain. So we're all strapped on for that interesting ride. We are very clear on what we can do in this space and what we cannot do. We just want to strengthen on that, on what we can do, and look at adjacent areas where some of the skills that we have, some of the experience and knowledge that we have can be brought to the fore.
Yeah, so that sort of brings us to the end of this discussion, but great knowledge that we have received from your end, and the perspectives are brilliant to hear from your side. And we definitely wish all the best for Ignitarium to, for its new initiatives and the innovations that it's bringing, for the industry. And thank you so much, Pradeep, for joining us for this session once again. Thank you.
Yeah, thanks a lot, Srijati. Happy to be part of this.
Thank you.